Alrighty, so we're going to start by looking at the key from last night's homework. Since I'm not there to show it to you, I thought I would just put it on the video and you can check it with what you did last night. So I'm going to scroll pretty quickly. You can always just pause it to go back and check your answers. Again, feel free to pause if you missed part of this. Go back. Alrighty, so what we're going to do now is continue our discussion about completing the square. Really, you're not learning anything new today. I'm just showing you a couple of weird problems and how that affects our work towards completing the square. Number one here is completely normal. It is just like all the problems from yesterday, so I am going to very quickly go through it to save time on this video. If you feel like you've got it, feel free to pause me or skip past me. It's totally fine. You won't offend me. So I'm going to start by adding the 9 to the other side. Then I need to figure out what value I can add in here to create a perfect square trinomial. So I'm going to cut this 8 in half and get 4, square it, and I get 16. And we're going to add it to both sides. Then I'm going to do the perfect square trinomial. I'm going to factor this. So I get x plus 4 squared equals that's 25. Then I square root both sides. So x plus 4 is 5, and x plus 4 is negative 5. So my two answers will be 1 and negative 9. Okay, again, nothing weird there. That's just kind of to recap. Number 2, the only thing weird on number 2 is the fact that it's not in standard form. So you want to make sure you kind of rearrange things so that you're set on what's what, what's A, what's B, what's C. So you'll notice that on the step list over here, there's now a different step 1. It says put in standard form. So on number 2, I'm going to go ahead and move this x squared over. In the same step, I'm going to also add the 13 over here. Okay, so again, it's the same exact process. It's just making sure that you're aware of what's what before you get started. So now I can finish out the problem. Half of 12 is 6. So I'm going to add 36 to both sides. We're going to factor. Then we square root. So our two answers are 1 and negative 13. Okay. Number 3, the thing that's weird about number 3 is the fact that we have a greatest common factor that needs to be taken out before we get started. Because you'll notice 2x squared is not a perfect square. And even if I move this 4 over, it's still going to be impossible to create a perfect square trinomial. So before I do anything at all, I'm going to go ahead and take out a greatest common factor. Okay, so I'm going to take out a 2 from everything. Okay, now this next step, I don't really want that 2 to be there anymore. So what I'm going to do is I'm actually going to go ahead and divide by the 2 right now. And you'll notice that all I have left is x squared plus 8x minus 2 equals, well, 0 divided by 2 is just 0. So really, when I took out that 2, I was just getting rid of it altogether. And you can do that. We mathematically didn't do anything wrong. So now I continue on with all of the same steps to solve this using completing the square. So again, I'm going to do the rest of this part pretty quickly. Move my 2 over, figure out what goes in here, which is 16. Then I factor. You'll notice 18 is not a perfect square. So whenever I take my square root here, I have x plus 4 equals plus or minus the square root of 18. So when I subtract my 4, my answer is negative 4 plus or minus the square root of 18. Okay, number 4 is exactly the same as the one we just did. Nothing weird other than the fact that you need to factor before you get started. So when you look at this problem, all of those have a 5 in common. So I'm going to take out the 5 before I do anything else. And really, because I can just divide by 5 on both sides and it disappears, I really could have just taken out the 5 from the get-go and gotten started with the rest of the problem. So from here, it's normal. I'm going to go ahead and add my 2 over. Figure out what I need to add in here, which would be a 4. Factor. When I go to take the square root, I notice that this is not a perfect square, but that's okay. So x minus 2 equals plus or minus the square root of 6. Oops, add the 2. So x equals 2 plus or minus square root of 6. Number 5, exactly the same as what we've been doing. I would go ahead and pause at this point and try it now that you've done 3 and 4 with me. It's the exact same thing. You need to factor out the greatest common factor before you get started. So go ahead and pause it now, and then when you resume it, you should have your answers in front of you worked out. Alrighty, so there's that one worked out. Hopefully you were able to handle that, taking out the 3 from the get-go, but then completing the square like we've been doing for the rest of it. Just a few more. Number 6 is actually a completely normal problem. There's nothing weird about it at all. It's just review. So again, I would go ahead and pause and try number 6 on your own. Alrighty, so there's number 6 worked out. Again, completely normal. Could have done it yesterday. No problem. All right, number 7. So the only thing that's weird about this one, well, I shouldn't say that. The first thing that's weird about this one is it's not in standard form. So again, I'm going to kind of do some rearranging here. I'm going to put my 4x squared over here, and I'm going to go ahead and move my 9 to the other side. Okay. Now again, I need to take out a greatest common factor, except that 4 and 8 have something in common, but 9 does not, right? I don't have a greatest common factor between all 3 of these. So instead, I'm going to notice that this is actually already a perfect square. So I can go ahead and complete the square where I'm at, even though there's a coefficient in front of the x squared. I can still make this work, because the square root of 4x squared is 2x. So I need to think about, okay, the square root of what over here, when I combine it with 2x, is going to double to 8x. Well, going backwards, 8x before it was doubled was 4x. And if this 2 contributed to half of that 4, then I need another 2 over here, which means I need a 4 right there. Okay, so it's a very similar problem to what we've been doing, just a little bit harder to think through because your first term here needed to be considered in order to complete the square. Okay, so really what we ended up with, this right here, when I factor it, is 2x plus 2 all squared equals 13. Then I square root both sides. There is no whole number square root of 13, so I'm just going to leave it as plus or minus square root of 13. I'm going to subtract 2 over here. So I've got 2x equals negative 2 plus or minus square root of 13. And divide by 2. So my final answer looks crazy and complicated, like this. Okay, just one more. This one, pretty straightforward. You just need to rearrange and take out the greatest common factor. I'm going to move my 12x over. I can actually go ahead and just divide by 6 everywhere. If I divide this by 6, I get x squared. Divide this by 6, I get 2x. Divide this by 6, I get 8. Then we can continue with completing the square. So I'm going to add in a 1 here, add in a 1 there. Subtract 1, and there's our 2 answers. So again, just to recap, the only things that we added in today is that sometimes you have to rearrange your equation so that you have a and b on one side and c on the other. And then sometimes you have to divide out a greatest common factor. But really that's it. Everything else is the same as it was yesterday. It's just a matter of practicing and getting comfortable with it. So let me know if you have any questions when I return, and I would be happy to answer them.